Hello and welcome to my YouTube channel. Today we are going to demystify a buzzword you hear almost every day, machine learning or ML for short. You might think ML is a science fiction, robots taking over the world or flying cars. But the truth is you probably used machine learning 3 or 4 times before you even finished your morning coffee. Did you unlock your phone with your face? That's machine learning. Did you ask Siri or Alexa about the weather? That's machine learning. Did you check your email and notice the spam folder got some junk? That is also machine learning. So what exactly is it? In simple terms, machine learning is a branch of artificial intelligence, AI in short. Traditionally, computers were like every obedient calculators. Human had to give them exact step-by-step instructions for everything. If you didn't write a rule for it, the computer couldn't do it. The core concept data. To understand ML, you only need to understand one key concept: pattern recognition. Imagine you want to teach a computer to recognize a cat. In the old days, you would have to write code that says look for 2 triangles on top, that is ears, whiskers and a tail. But what if the cat is facing away? What if the cat has floppy ears? Your code would fail. Machine learning, you don't define ears or tails. You simplify, feed the computer thousands of photos labeled cat and thousands of photos labeled not a cat. The computer analyzes these pixels and finds the patterns that humans might miss. It learns on its own that this specific shape usually means a cat. This process is called training. Once it's trained, you can show it a photo of a cat it has never seen before and it will say that's a cat. The 4 types of machine learning. First one is supervised learning. In this scenario, we give the computer data that is already labeled. We tell it the answer. For example, we give it emails and tell it this one is safe and this one is spam. The computer studies the difference. Later, when a new email comes in without a label, the computer predicts the label based on what it learned. Real life example, predicting housing prices. We show the computer data of 1,000 sold houses, their size, location and the price they sold for. The computer learns the relationship between size and price. Then if you show it's a new house, it can predict how much it might sell for. Second one is unsupervised learning. Here we give the computer a massive amount of data, but none of it is labeled. We don't tell it what the data is. We just say, here is a pile of information. Find the hidden structure. Imagine giving a toddler a bucket of mixed Lego blocks. Even if you don't tell them what colors are, they might naturally start separating them into pills, and a red pill, a blue pill and a yellow pill. They notice the pattern on their own. Real life example, customer segmentation. A shopping website might look at millions of shoppers. The algorithm notices that people who buy baby diapers often buy a baby formula too. It grouped these people together even though no programmer explicitly told it to look for parents. Third one, semi-supervised learning. Labeling data is expensive and takes time. Imagine having to sit and name 10,000 photos by hand. That's exhausting. In semi-supervised learning, we label a small amount of data and leave the rest unlabeled. Real life example, Google Photos or Apple Photos. You might label your face in just one photo. The system then scans your entire library of thousands of photos, uses that one labeled as a guide and successfully identifies you in all others. Reinforcement learning, that is fourth one. There is no data set here. Instead, we put the machine called an agent into an environment and tell it to figure out it. If it does something good, we give it a reward, positive points. If it does something bad, we give it a penalty, negative points. The machine tries random things, fails a miles times, but even actually figure out the strategy that gives the most reward. Real life example, self-driving cars. You can't program every possible traffic solutions. Instead, the car learns stopping at red light equals to good reward, crashing equals to bad penalty. Over time, it learns to drive smoothly to maximize safety. Applications of ML. So we have these amazing way to teach computers, but what we are actually doing with them? The applications are transforming our world right now. Healthcare. ML is saving lives. Algorithm can scan X-rays and MRI scans faster and sometimes more accurately than human doctor to detect early signs of cancers or heart disease. It helps helps doctor makes better decisions faster. Finance. Banks use ML to protect your money. Whenever you swap your credit card, an ML model instantly checks that transaction against your usual spending habit. If you live in New York but your card is suddenly buying a yacht in Italy, the system flags it as a fraud in milliseconds. Entertainment and retail. This is the Netflix effect. Recommendations are powered by ML. Netflix, Spotify, and Amazon don't just guess what you like. They analyze what you watch, how long you watched it, and what other people like you watch. They tailor your experience specifically to you. Transportation. Beyond self-driving cars, ML helps you with logistic. Apps like Google Maps or Uber use ML to predict traffic jams before they happen, calculating the fastest route by analyzing the movement of thousands of other phones on the road. Conclusion. To wrap up, machine learning is simply a tool. It is the science of getting computer to act without being explicitly programmed. Whether it is supervised, unsupervised, semi-supervised, or reinforcement learning, the goal is the same: to turn raw data into actionable intelligence. Thank you for listening, and I hope you now have a clear picture of the amazing world of machine learning. Thank you so much.